So, picking up where I left off, I actually just went and deployed the Google hipster shop. Here is the lovely hipster shop, Cloud Native Service Microservices demo. And it into your microservice application. That's cool. So, what you can see is this app is relatively complex. There's a mixture of languages here: Go, C#, Node.js, etc. Now, this is also sending requests running all over the place. So I've already gone and deployed it, and I use the pre-built container images. So now, you can see here, we've got some of the stuff already running. Now, what's interesting is that picking up where I left off, just to remind you, was that we were seeing pretty significant disk latency after just installing istio. So now, what we can see is that after deploying just the hipster app on top of istio, you can see that disk IO saturation at the launch of the application immediately spiked. This caused plague and other runtime errors on those hosts. Additionally, we can see that, things are, CPU utilization went up, that's good. CPU saturation, these are all fairly normal. But here, again, this is the critical failure. During this period of time, all of the sandboxes were failing. He is having repeated issues trying to go and get, disk IO time. These are pretty consistently popping up across every one of the nodes. Here you can see all of the Grafana nodes, or rather Grafana pods, are having issues reading and writing to their file system. If we go back to the kubelet view, as I showed you before, you can see that the operation rate went up. This is our spike from earlier, and this is our spike now. And so, as you can see, pull image obviously got heavily throttled. Additionally, create container was also throttled. The spike in load generally comes from the container image pull. After that, it's a matter of the disk IO, deployment status, and other IO in the steady state application. Now, let's see here, 1600, a little bit of load average spikiness here. Memory utilization, nothing too fancy. Disk IO, okay, we can see a lot of chatter on dev SDA. SDA IO time, this is another key metric here. Here, as you look at disk IO, each one of these, I have a feeling, yes, the cluster, it's still flapping on itself. It's going to keep doing that pretty much until I shut it down. So, as I was saying, disk IO, you can see a direct correlation to bytes written. Well, rather, you can't see a Alexa, set a timer for 10 minutes.
10 minutes, starting now.
Here, we're looking at the node report for node 3. Here we can see node 3 is still having a really tough time with life. Here you can see partly why. You can see the SDB IO time, pretty, flat. There's nothing happening to it. But here you can see this red line is the IO time spent writing to dev SDA. This is your OS disk. This is shared by Docker, logging, kubelet, you name it, it's there. Here you can actually see in blue, there isn't a lot of storage bandwidth being consumed. That's because this problem is not a bandwidth problem, it's a file operation. File operations are atomic. Every time you make one, that counts against the overall quota on the OS disk. This is why it's critical to isolate your data paths. But what's key here is that you would not necessarily know that the issue was happening if you were looking at only these metrics. Disk IO, SDA IO time, SDA IO time, or rather, IO time in general, will generally be spiky like this when you see an increase in load. What should not happen is the failure of the container runtime. Here, we'll see an example of what the pod sees, at least in this particular Prometheus pod. Some pods will see file not found if they're trying to read off a disk. In this case, what we see is that in the previous incarnation of this pod, it actually failed to connect. Right? This is another case where networking, because it's CNI, is very sensitive to the disk latency as well. This is another example of pod logs where you can see there was just an unhandled exception, and you would see this dial TCP IP IO timeout. You see this a lot if the connection is so, or rather if the disk is so saturated and latency is so high that you're trying to actually contact the API server itself, and you will get similar errors from kubectl as well.